Hello and welcome back to Summer Work Help for Calculus 1. In this video we're going to be taking a look at question number 16, and the directions here are fairly straightforward. Simplify. So, taking a look at question part A. So part A says 1 over sine of theta. So I guess maybe it's debatable as to whether this would be considered simplifying or not. Basically, when we say simplify in this context, we're basically saying, rewrite the trigonometric expression using a different term, essentially, right? So in order to answer this question, you're going to want to remember sort of how the trig functions kind of relate to each other. So there's 6 of them. So we've got sine, cosine, tangent, cotangent, secant, and cosecant. And I like writing them like this because if you write them like this, these are the trig functions that are reciprocals of each other. So what I mean by that is, like, let's say we're talking about, this middle line here. It's saying that 1 over cosine is secant, and 1 over secant is cosine. Right? And so these are just some relationships between the trig functions that we do in fact want to try to remember. So we're talking about 1 over sine. Well, 1 over sine is one way for you to write cosecant. And so my answer for 16A is cosecant. And again, it's debatable as to whether or not this would be considered simplified or not. On the one hand, our answer is not a fraction, and so it's like kind of simpler, I guess. It's kind of like nicer. I guess the downside is that we have to introduce, one of the other trig functions, cosecant, whereas sine and cosine, the two of them are like the basic trig functions. So it could be worth keeping sine in it, even though it would be 1 over. But I think given the context of this problem, just trying to get you to recognize that 1 over sine can be rewritten as cosecant of theta. Part B. Well, part B is very similar, and in fact, in my explanation, I kind of already said the answer. So instead of rewriting it, I'm going to go back. So again, notice that cosine and secant, if you write them in the order, if you go like 1, 2, 3, 4, 5, 6, like that. Notice that cosine and secant are kind of across from each other, so those are the reciprocals, the reciprocal identities. So just like before, if you had 1 over cosine, well, that is secant, but instead we have 1 over secant. Now this, I don't think there's much ambiguity here. In this problem, you would almost certainly, in just about every context, want to, quote, simplify this into cosine of theta. And that's our answer. And again, the reason why this one is maybe a little bit more straightforward than part A is that by doing this, not only do we get rid of our fraction, I mean, cosine is still a fraction. Cosine is, x over r, or it's, adjacent over hypotenuse, but just it doesn't look like a fraction. So we've definitely been able to simplify it by just writing it as a single trig function, and almost like even better is that we're now dealing with cosine as opposed to secant. And again, the building block functions are sine and cosine. Tangent is kind of like in its own category, and then there's the other 3, cotangent, secant, cosecant. So anytime that we can kind of work with sine or cosine or tangent as opposed to the other 3 trig functions, that's in a vacuum, that's like better. Now, obviously, each problem is different. Maybe you have to use the other trig functions, but for this problem, I would say that 1 over secant most of the time you would probably want to write that as cosine of theta. So that's question B. Okay. Question C. So question C says we've got an expression here, tangent of theta times cosine of theta plus cosecant of theta over sine of theta. So if you're simplifying an expression that involves a whole bunch of trig functions, there are some various strategies that you can try to, see if you can make some progress here. One sort of like catch-all strategy, like if you don't see another way to do it, one thing that you can try is you can try rewriting all of your terms in terms of sine and cosine. All right, and all 6 trig functions, sine, cosine, tangent, cotangent, secant, cosecant, all of them can be rewritten in terms of just sine and or cosine. So let's go piece by piece and rewrite some of these things. So we've got tangent of theta. Well, tangent, good thing for us to remember here, tangent is sine over cosine. All right, so tangent can be rewritten as sine over cosine. So that's what I'm going to do, and we'll see if that helps. So tangent, we're going to say, I'll go back to my original color here. So tangent is sine over cosine. Then we've got times cosine plus, well, cosecant is 1 over sine. And then I've got divided by sine. So first of all, if you don't see this, notice that when you have a fraction like this is for any fraction, not just trig, but any fraction, I can sort of pull out the numerator almost like as a coefficient, and then the second term becomes a fraction of just the denominator, and then you've got like a placeholder of a 1 in the numerator. So if you don't see that, I would get comfortable with that, because again, that's not trig. That's just like how fractions work. So what I have here is I've got 2 trig terms, cosecant and then sine. Well, I said we were going to write everything. No, we should stick with the original plan. So I said that, again, one strategy here is to just rewrite everything in terms of sine and cosine. Well, cosecant is 1 over sine. Right, so I've rewritten cosecant, which is the numerator of the fraction, as 1 over sine, and then you've still got another 1 over sine. That's the original sine in the problem. So if I take a look at what I have here, well, my first term, I have sine of theta divided by cosine of theta times cosine of theta. Well, those cosines cancel. So my first term is just sine of theta plus, and then I've got 1 over sine of theta times 1 over sine of theta. Well, that can be rewritten as 1 over sine of theta. Now, you want to be very careful when you are squaring trig functions, okay? What you don't want to write is you don't want to write this, ever, okay? And the reason why you don't want to write that is because it's confusing. Are you saying sine of theta squared, right? Or are you saying sine of theta? Now, this pen is, let me use a different color here. This pen is a little, all right, I'll change the I'll change this. There we go. Okay. So, as I was saying, if you write something like sine of theta squared, it's confusing because it can't really tell, are you saying sine of theta squared? Or are you saying sine of theta squared? Those are most certainly not the same thing, okay? You will practically never get the same answer doing those two things. Those are two very different things. So it's a little confusing. Now, if you, like it's confusing on paper. In reality, the chances of you squaring an angle measurement and then plugging that into a trig function are pretty small, right? So you probably won't see this very often, right? Just there's not many contexts in which you would square an angle measurement, but you could theoretically. So the point is, because of that ambiguity, you don't want to write just the squared at the end like we did here, right? So I'm going to erase that. But the other problem is, if you do this, well, you end up squaring trig functions a lot once you get to a certain level of mathematics. And like if you have an entire like page of just all these trig functions getting squared or cubed or whatever, you've got all these parentheses all over the place. It just makes it look a lot messier and a lot more complicated than it is, right? Parentheses are useful, but it's also like if you can get away without using them, it's like better. And again, this comes up often enough that we want to sort of be able to express this, but without using the parentheses. And so when you square a trig function like this, you can write it as sine squared theta. And again, just to be like abundantly clear here, when you say sine squared theta, what you are really saying is you are saying sine of theta, right? Get whatever that is, and then square the result. Okay? You can't really just square sine because that's a function. You need a value, right? Sine of theta is a value. Sine by itself is just a function, but there's no quantity to square there. So again, just to sort of save on writing parentheses over and over again, when you say sine squared theta, that's what we're talking about. So that could be your final answer. But then we kind of saw this in A, where if you want to express this where there's no fractions, you could, I mean, the first term is just sine, but then notice that you have 1 over sine squared. Well, again, 1 over sine is cosecant. And so you could express your second term as cosecant squared theta, because that way it gets rid of the fraction, which could be considered simpler. But it does mean you're now talking about a different trig function than sine. So I would say for this problem, unless your teacher says otherwise, in which case I wouldn't argue with them, for now I'd say either are fine. And then maybe in class, if your teacher's looking for something specific, they could maybe clarify that. But for now, I'll say that either one of those is better than the original and the original question, right? So we have definitely simplified this. It's just kind of a question of like which one's better. But both of them are definitely better than what we started with. So that's part C. All right, part D. So speaking of squared, we have an expression here that says sine squared theta plus cosine squared theta. So this is something called a Pythagorean identity. There are, in trigonometry, there are 3 of them. This is one of them. And it's also, of the 3, it is by far the most important one. Okay? So each Pythagorean identity involves 2 of the 6 trig functions. So this one involves sine and cosine, and then another one involves 2 more, and then another one involves 2 more. And this is a good thing to know. Now, maybe some of you have not seen this before, and that's why we're going over it now. I'd rather you see it now. This is a very handy identity in mathematics. And again, an identity is basically something that's like always true, right? So as a real basic identity, x plus x equals 2x, right? That's an identity, right? When you take an x and add another 2x or x and you get 2x, you can kind of bank on that always being true. So that's an identity. This is another identity, and we're saying, all right, well, what does this equal? And before I tell you what it equals, I do just want to point out here that you may remember that on the unit circle, I'll do just the first quadrant here. So this is quadrant 1, and this is a piece of the unit circle, okay? You may remember, or you should remember, that on the unit circle, your x and y coordinates, well, your x coordinate is sine, and your y, oh, no, sorry, my bad. Okay. Your x coordinate is cosine, and then your y coordinate is sine. And notice that if you form a triangle here, right, where theta would be right there. Well, this is your x value, and this is your y value, which means this is cosine of theta, and it means that this is sine of theta. This is a right angle. Notice that if you have sine squared, well, that's this, right? That's sine of theta. So you're going to square that. Okay, so that's your y coordinate squared. And then down here you have x, and we're going to square cosine of theta. So then you've got plus x squared. Well, think about what we're doing here. If you take a look at this triangle, if you set it up so that you take x squared plus y squared, well, guess what? That's going to be your hypotenuse squared. And on the unit circle, by definition, the reason why it's called the unit circle is that the radius is 1 unit. And notice that I'm going from the center of the circle out to the circle itself, which means your hypotenuse is, in fact, 1. So what you end up getting is you end up getting this equation of x squared plus y squared, or y squared plus x squared, equals 1 squared. Because that's the Pythagorean formula, theorem. The Pythagorean theorem says that if you take the legs of a right triangle, you square each one and add them together, you will get the hypotenuse squared. And on the unit circle, your hypotenuse is the radius, and so it's 1. So we're really just taking your x value, squaring it, taking the y value and squaring it, because that's what sine and cosine are, or cosine and sine are. So you end up getting 1 squared. But of course, 1 squared, well, that's 1 times 1, which is 1. So this is actually a very handy and powerful thing in trigonometry, and we use trig in calc, so it's also useful in calc, that if you take any theta, right, so this could be any angle you want, and if you take the sine of that angle and you square the result, and then you take the cosine of that angle and you square the result, and you add them together, you will always get 1. And you can try it on the calculator. It doesn't matter if it's in degree mode. It doesn't matter if it's in radian mode, right? Doesn't matter. It could be a negative angle. It could be a huge angle. It could be on the unit circle. It could be something that doesn't appear directly on the unit circle. I mean, technically all angles are on the unit circle, just some of them are labeled and some of them aren't. But as long as your values for theta are the same, right, that's key, all right? So theta has to be the same number. But as long as you use the same number, as long as you do this correctly, you should get 1 every single time. And again, this is what's called one of the 3 Pythagorean identities. You can get the other two by either dividing everything by sine squared or dividing everything by cosine squared, and that's how you can derive the other two Pythagorean identities. So I'm not going to do that right now. I'm going to wrap up the video here. But just understand that there are three Pythagorean identities, and that this one, of the three, this is the one. If you had to pick one, this is the one that you really do want to know, which is sine and cosine. So sine squared of an angle plus cosine squared of an angle will always result in the number 1, and that's one of your Pythagorean identities. So zoom out here, and those are our simplified answers for question number 16.